On separate diagrams, sketch the curve with the equation y equals modulus of 3x plus 3. Sketch the curve with the equation y equals modulus x squared minus 1. Solve the equation modulus 3x plus 3 equals modulus of x squared minus 1. Hence, solve the inequality modulus 3x plus 3 is less than modulus of x squared minus 1. So, this is what we've got then. Let's have a little look at it. This is the question summary form. Sketch this. Well, all we have to do, I'm just going to do an informal sketch. Clearly I would use a ruler if I were in an examination, but I'm just going to sketch it ad hoc here with this digital pen. So here's the axes then. I'll just copy that because we're going to do it twice, aren't we? So let's just copy that. And then I'll just replicate it over here as well because we're drawing two functions, aren't we? So we want to draw modulus 3x plus 3 here. What we can do is I'm going to do a dashed line to denote the line. 3x plus 3 is a fairly steep line, probably steeper than what I'm drawing here. But there's the line, the linear line, 3x plus 3, y equals. Intercept is 3, and the gradient is 3, isn't it? But because it's the modulus, the negative values here need to flip up, so we need to reflect that upwards, don't we? So we can draw in our vertical side, this side here then. And there's the true line, isn't it? So let's get rid of these that we drew initially. Okay, and this value here, let's put that in as well. So this is the origin, I'll put it over there. This value here then, well, when does this equal 0? It equals 0 when x is minus 1. So there's the modulus then of, so we can put it as a modulus now, can't we? Because it's this line here. And this line, x squared minus 1 modulus, well, if we draw the quadratic x squared minus 1, it's going to look like this. We know that this x squared minus 1, it cuts the axes and has roots at 1. This is 0 when x is 1, or x is minus 1, isn't it? Now, because it's the modulus, these values underneath are flipped up, upside down. So it goes around like so. This value here is 1 then, isn't it? Because this would be minus 1. So we can get rid of the underside, the negative part, because we're taking the modulus there, aren't we? Oops. Let's just get rid of this. That's enough to tidy it up. So we've got our origin. So here's the modulus of x squared minus 1. So we've sketched both of them, parts 1 and parts 2 of A. Solve this inequality then. So when do they equal one another? Well, these 2 points coincide. This line, this is part of a quadratic. It's not a straight line. It may look like a straight line there. It's not meant to be a straight line. It's meant to be a quadratic. So I'll emphasize that here. Like so. Now it's going to come round and go up, isn't it? Like so. And the gradient of 3 is going to be steeper than what this is here. Because the derivative is 2x of this line. When x is minus 1, the derivative will be minus 2. This derivative is minus 3. It's a steeper derivative. So this goes up sharper than this goes up from minus 1 and going negative. So basically the line, the straight line, is going to be steeper. So this is going to cut underneath and then go on top. So when do they equal? Well, on this side of minus 1, they're going to equal each other at minus 1 by inspection. So that's one value. When the this is equal to this modulus is equal to that modulus. But the other one will happen when this negative side, so this negative side of the line will be minus 3x minus 3, run a minus through it. When that equals this part of the line, which is x squared minus 1, that value there, when does that happen? We need to find this side on the left hand side of minus 1. So this implies x squared, move the 3x over, move the 3 over, minus 1 plus 3 is plus 2. So we get our x plus 2, x plus 1. So that tells us that x equals minus 1 and minus 2. So we've already got the minus 1 because we saw that by inspection, and the minus 2. So that's when they're equal. And this, as we say, this part of the quadratic, so to speak, swings underneath and cuts in there at minus 2. So if you were drawing it as a, not that we want to overdraw it, but I'm just highlighting it here, just for the purposes of part B. So we've done that then. Now solve this. So we've done it that side. Now this straight line goes through at gradient 3. So basically gradient 3 here is going to, although it doesn't look it, is steeper than this gradient, because this gradient is 2x. This gradient is 2 and this gradient is 3. So it's going to go up steeper and it's going to cut up here somewhere and they'll intersect up here. So for x, when x is bigger than minus 1, then in that context over here we're interested in when basically when does this line 3x plus 3 equal, actually it'll cut this line, it's not going to cut that one because it was steeper than this shape here. So when does it equal x squared minus 1? Let's find the solution then. We'll get x squared, move the 3x over minus 3x, and then move the 3 over minus 4. So we then get x 4 and 1 with a minus and a plus. So we can see that x equals minus 1, which is what we knew anyway at the outset, and also the value of 4. So that's when this line, the straight line here, cuts into this graph. So that was part 1. Then we've done the solutions. We've got those 4 solutions. 3 solutions rather, minus 1, minus 2 and 4. So now part 2, solve this inequality. When is the modulus 3x plus 3 less than x squared plus minus 1? So part 2, when is the modulus of 3x plus 3 less than x squared minus 1? Here, what do we get then? When does the line, this line, cut underneath this quadratic? Well, it would be for x bigger than 4, wouldn't it? And it has to be x bigger than 4 because this is less than, and it also, if you look on the other side of the graph, this line, as we said, was steeper, so it's going to cut this. Here's the quadratic. The line is underneath the quadratic here at less than minus 2. So there's our solution set for part 2.